Hello everyone, my name is Leanne Smith and today we are going to talk about one-way and two-way ANOVA. Our objectives are learn about where one-way and two-way ANOVA originated, define one-way ANOVA and two-way ANOVA, and describe the ANOVA model and assumptions, provide some examples of research questions, and walk through the steps on ANOVA and two-way ANOVA in SPSS. The one-way and two-way ANOVA originated with Sir Ronald Fisher. He was an influential British statistician and geneticist, and he is responsible for developing the analysis of variances, which is ANOVA, maximum likelihood estimation, and Fisher's exact test. He's highly regarded. One-way ANOVA is a statistical test used to compare the means of three or more groups. The assumptions for one-way ANOVA are independence, each group are unrelated to one another, normality, the dependent variable is normally distributed, homogeneity of variance, the variances of the groups are equal. One question that I came up with that you could use with one-way ANOVA would be, do different teaching methods produce different results? The research question aims to examine whether different teaching methods produce different outcomes. One-way ANOVA analysis can be used to compare the means of the academic outcomes of three or more groups of students who have been exposed to different teaching methods. Two-way ANOVA. The two-way ANOVA model is a statistical test used to analyze the effects of two factors on a continuous response variable. It's an extension of the one-way ANOVA model. Assumptions for this are independence, each group are unrelated to one another, normality, the dependent variable is distributed normally in each group, homogeneity of variance, the variance of the groups are equal. Independence of errors. The errors are independent and equally distributed. A question I came up with for this would be, how do different instructional methods impact student achievement in various learning environments? Two-way ANOVA can be conducted here to compare the means of academic outcomes in different instructional methods across two independent variables, instructional method and learning environment. So in SPSS, if you want to run a one-way ANOVA, first you will click Analyze, Compare Means, and then One-Way ANOVA. Then you will add the three dependent variables, grades, math achievement, and visualization to the dependent list. And then under Factors, you'll add Father's Education. Under Options, you'll add Descriptive and Homogeneity of Variance. Click Continue, and then you get your tables. Table 1 shows the means to be compared. Table 2 shows the test assumptions of equal variances. You see the significance here. And Table 3 shows the F and P between the groups. So the F stands for the variability between groups relative to the variability within groups in an ANOVA analysis. And then you have your significance here. The ANOVA output indicated significant variations among the three groups of father's education levels on high school grades and math achievement. If you want to determine which pairs of father's group are distinct, you would require a post hoc multiple comparisons test, which would be determined which test you would do by the Levine's test. Two-way ANOVA SPSS. The question here is, are there differences in math achievement for people varying on math grades or father's education revised? And is there a significant interaction between math grades and father's education on math achievement? First, you would click Analyze in General Linear Model and Univariate. You would add math achievement to the dependent variable. Your fixed factors would be math and father's education. Then you would add father's education revised on the horizontal axis, and on the separate line you would add math grades and click Continue. Then we would click Descriptive Statistics, Estimates of Effect Size, Observed Power, and Homogeneity Tests, and then click Continue. Interpretation. It indicates that 73 participants in the study, 43 reported having less A or B, and 30 reported most A and B. The father's education level was included, and 38 participants had a high school diploma or less, 16 had completed some college, and 19 held a bachelor's degree. Displays the descriptive statistics here. Math achievement is a dependent variable here, and the fixed factors under evaluation are math grades and education. In Table 3, this is the Levine's test of equality, errors, and variances. It evaluates the variances in homogeneity. Or the results from the Levine's test suggest significant differences in the area variances for the math achievement test between the groups, with all tested methods being statistically significant. It suggests a possible violation other than variance homogeneity assumption in this analysis. On Figure 1 of the profile plot 9, it appears that math achievement is generally lower for students with fathers who have lower levels of education. Conversely, for students whose fathers hold higher education levels, difference in math grades have a more noticeable effect on math achievement. However, it's imperative to confirm the conclusion using inferential statistics. Thank you for listening to my PowerPoint, and I appreciate your time.